Have you ever looked up at the night sky and wondered if we're truly alone? This question has fascinated humanity for centuries. Are we the only intelligent life in the universe, or is Earth just one of many worlds with life? Today, science gives us tools to move beyond speculation and actively search for answers. Our sun is just one of hundreds of billions of stars in the Milky Way, and our galaxy is one among trillions. With so many stars and planets, it seems unlikely that Earth is unique. The search for extraterrestrial life pushes the boundaries of technology and imagination. We're not just dreaming anymore, we're investigating. This quest challenges us to define life and imagine how it might exist on worlds very different from our own. The universe is a vast stage, and it feels like there should be more than one actor. So, let's explore the science and possibilities of finding life beyond Earth. We'll look at what life needs, where it might be found, and how we're searching. We'll also confront the mystery of why the universe seems so quiet. The search for life is about understanding ourselves and our place in the cosmos. Are you ready to explore the universe with me? Before searching for life, we need to know what to look for. On Earth, life thrives everywhere, but it always needs a few basics. The most crucial ingredient is liquid water. It's the medium for life's chemistry. So, our first step in the search is to follow the water. A stable energy source is also essential. Most life on Earth relies on the sun, but some use chemical energy deep in the oceans. A planet's star must be stable. Too much radiation or instability can wipe out life before it starts. The planet must be in the Goldilocks zone. Not too hot, not too cold, just right for liquid water. Life also needs the right building blocks, elements like carbon, hydrogen, nitrogen, and oxygen. Carbon is especially important because it forms complex molecules, the backbone of life. Luckily, these elements are common throughout the universe, forged in stars and scattered across space. A habitable planet also needs stability, a protective atmosphere, a magnetic field, and a steady orbit. These shield life from harmful radiation and extreme temperature swings. So, our recipe for a habitable world: liquid water, energy, the right chemicals, and a stable environment. The search for life is really a search for worlds with these ingredients. With billions of planets out there, the odds are promising. But finding the right combination is the real challenge. Now that we know what to look for, let's consider the scale of the universe. The Milky Way alone has hundreds of billions of stars, and now we know most have planets. Thousands of exoplanets have been discovered, and new ones are found all the time. On average, every star likely has at least one planet, meaning hundreds of billions of planets in our galaxy. How many are like Earth? Estimates suggest up to 10 billion Earth-like planets in the habitable zone of sun-like stars in the Milky Way. And that's just our galaxy. The observable universe contains hundreds of billions, maybe trillions, of galaxies. Multiply that by billions of potentially habitable planets per galaxy, and the numbers become staggering. With so many possible worlds, it seems likely that life could exist elsewhere. The universe is overflowing with real estate for life. But with all these possibilities, why haven't we found any signs yet? The search continues, and every new discovery brings us closer. The odds seem to favor life existing somewhere else. The real question: are any of those worlds inhabited? The search for life is more than numbers. It's about discoveries that change our view of the cosmos. The first exoplanet around a sun-like star was found in 1995, proving planets are common. Since then, we've found thousands, from giant gas worlds to rocky Earth-like planets. The TRAPPIST-1 system, just 40 light-years away, has 7 Earth-sized planets, 3 in the habitable zone. Imagine a sky with 6 other worlds visible, some as big as our moon. These discoveries make the possibility of life elsewhere feel real. We're not just imagining other worlds, we're mapping them. We've also detected strange signals like the famous WOW signal in 1977, a powerful, unexplained radio burst. More recently, fast radio bursts, FRBs, have puzzled astronomers. Most are natural, but some repeat from the same spot, raising questions. While there's no evidence these are alien messages, they remind us the universe is full of surprises. Each signal keeps us listening, hoping for a breakthrough. The search is ongoing, and every new discovery fuels our curiosity. One day, a signal might be the one we've been waiting for. Until then, we keep our ears and minds open. How do we find distant planets and listen for cosmic whispers? Our main tools are telescopes, both on the ground and in space. The Hubble Space Telescope has revealed galaxies and even studied exoplanet atmospheres. To find exoplanets, astronomers use the transit method, watching for tiny dips in a star's brightness as a planet passes in front. The Kepler Space Telescope used this method to discover thousands of planets. The James Webb Space Telescope JWST is a game-changer, using infrared light to study exoplanet atmospheres for signs of water, methane, or oxygen. Finding these biosignatures would be monumental. We're also listening for signals. This is SETI, the search for extraterrestrial intelligence. Massive radio telescopes scan the skies for signals that can't be explained by nature. It's like listening for a message in a bottle from across the galaxy. The search is patient and challenging, but the potential reward is enormous. With every new tool, our reach grows. The universe is getting smaller and more accessible every day. SETI, the search for extraterrestrial intelligence, is one of science's boldest quests. The idea, if other civilizations exist, they might use technology like ours, sending radio signals across space. SETI uses giant radio telescopes to listen for narrow-band signals, clear, focused transmissions that stand out from cosmic noise. The challenge is immense: billions of stars, countless frequencies, and no idea where to listen. To narrow the search, SETI targets sun-like stars and listens in the waterhole frequency range, a logical spot for universal communication. Despite decades of listening, we haven't found a confirmed signal, just tantalizing mysteries like the WOW signal. Some question the effort, but we've only searched a tiny fraction of the cosmic haystack. It's like dipping a cup in the ocean and declaring there are no fish. With better technology and more data, our chances improve every year. The search is just beginning. The universe could surprise us at any moment. This leads to the Fermi paradox. If life is likely, why don't we see any evidence? With billions of stars and planets, the galaxy should be teeming with life. So, where is everybody? Maybe we're not looking the right way, or aliens use technology we can't detect. Perhaps they're deliberately avoiding us, the zoo hypothesis. Or maybe intelligent life is extremely rare, and the leap from simple to complex life is nearly impossible. There could be a great filter, a step so difficult that few civilizations survive. It's possible we're the first, making us the universe's pioneers. Or, distances are simply too vast for contact. The galaxy could be full of isolated civilizations, each unaware of the others. The silence is a mystery that challenges us to keep searching. Even if we detect a signal, the challenges are just beginning. A message from 100 light-years away took a century to reach us. A reply would take another 100 years. Communication would be slow, more like exchanging postcards than having a conversation. Deciphering an alien message would be the ultimate intellectual challenge. Scientists expect a message would use universal concepts, like math and physics, to bridge the gap. But translating alien thought would be daunting. The discovery would raise profound questions. Who speaks for Earth? What do we say? It could unite humanity, or cause fear and uncertainty. We also can't assume aliens are like us. They could be artificial intelligences or something unimaginable. The gap between us and them could be vast. Communicating across such a divide would test our ingenuity and humility, but the attempt itself would be a defining moment for humanity. Why do we keep searching, despite the odds? Because curiosity and exploration are at the heart of what it means to be human. The search for life holds up a mirror to ourselves, making us reflect on what's important about our world. Even finding simple life elsewhere would be a monumental discovery, proving we're not alone in the universe. Discovering intelligent life would transform our understanding of science, philosophy, and our future. The search itself inspires innovation, unites people, and pushes us to dream bigger. Whether we find life or not, the journey is worth it. The quest to find others is really a quest to understand ourselves. The stars are calling, and it's in our nature to listen.